Hello and welcome to a video about transition elements. Please note that if you're doing double chemistry, this video doesn't refer to you. This part of the specification is for those studying chemistry only. That's those of you who are doing triple science. The transition elements are found in a particular part of the periodic table, right in the centre. They're all metals, and the chances are if you were asked to name a metal, you'd probably name a transition metal. Here are some of the common ones that you will have heard of. These ones, silver, gold and platinum, are often used in jewellery. And this one, tungsten, is used in light bulbs. As I said, they are metals, but they have quite different properties to the metals we looked at earlier from group 1. Transition metals all have higher melting points. They're stronger, they're harder, and they're much less reactive. They either don't react at all with oxygen or water, like gold and platinum, or they react very slowly over time, the way that silver tarnishes. As with the group 1 metals, all transition metals will form positive ions. However, the interesting thing about transition metals is that they form ions with a variety of different charges. These variable charges are also called oxidation states. You might come across this in other parts of the course. Because they can have a variety of charges, they have a particular way of being named so that it's clear what charge that particular ion has. So for example, copper 1, this means that the copper has a 1 plus charge. This would be copper 2 plus because of the Roman numerals 2 after the copper. Iron is Fe, it's got a Roman numerals 2 in brackets, so it's a 2 plus. This would be iron 3 plus, chromium 3 plus, nickel 2 plus, and manganese 2 plus. So whenever you come across the names of transition metals, you'll see these Roman numerals in brackets, and that just gives us an indication of what the charge is on that particular ion, remembering that they're always going to be positive charges. Another typical property of transition metals, which is different from other metals, is that they form coloured compounds. Each ion has its own characteristic colour. So for example, copper 2 is characteristically that bright blue colour you might recognise from copper sulfate. Iron 3 is a dark orange colour, which is the colour of rust. Chromium 3 is a very dark green, and manganese 2 is a very pale pink. The other interesting thing to note about transition metals is that they're useful as catalysts. We haven't talked about catalysts yet in the course, but you'll see them in more detail in the rates topic. In case you find these colours hard to imagine, here are some test tubes that show some characteristic colours of vanadium salts. That's all we need to know about transition elements for now. You'll come across them again later in the chemical changes topic, as well as when you look at electrolysis. For now, here is a list of the keywords we've looked at this topic in case you want to refer to them later. Thank you for watching, and hope to see you again soon at mygcsescience.com.